All right, section 2, let's talk about groundwater a little. So is extracting it the answer to the question of how we're going to manage our water resources in the future? Well, first of all, aquifers. Half of the world's population uses aquifers right now for their drinking water. So it is a substantial source. Just so you know, most aquifers are renewable. They can be recharged. The problem is if we are removing the water faster than it can be replenished, or we're contaminating it. And we are doing both of those two things in certain contexts. And so here's the picture of the United States. By the way, most of the groundwater depletion, it's a growing problem because of irrigation and for cropland. Remember we looked at earlier that 7% of the water on the surface is being used for irrigation. It's just the nature of growing food, it takes water. And so that's the main use for it. If you look in the United States here, if it's in red, this is places where we're overdrafting or we're sucking way more water out of aquifers than are being replenished in it. And so you can see in the southern Midwestern part of the United States, it's quite a common occurrence. You can see across the West, it's quite common as well. In arid areas, see in upper Wyoming, it's not a big deal. Yet, we have minor issues with it at the most. So most of Wyoming's not a problem, the southeast part of the state a little bit, but for the majority of the issue it comes in the southwest, or actually in this whole dry region right here, and then across the southern part of the United States. So that's where in the United States our aquifer issues are growing. It's not just a problem in the United States, it's around the world. Here's a picture of Saudi Arabia taken in 1986. You can see it's a fairly arid world. Over here's a picture taken in 2004. Each one of those green plots is a green plot that is a piece of cropland that's been fed by wells pulling from aquifers. And so you can see them scattered around. If you look closely, there's brown dots. The brown dots show you wells that have gone dry already. And so over the course of about 20 years or so, they've grown the amount of cropland they've had significantly, but they're already starting to see problems with that. And so it's an unsustainable problem. We talked about the Ogallala earlier, this huge, the largest aquifer, largest known aquifer in the world. And it goes across many different states: Wyoming, South Dakota, Nebraska, Colorado, Kansas, Oklahoma, Texas, and New Mexico. So it spans a long ways. The water table in many cases has been lowered by up to 30 meters, which is about 100 foot of water. That's 3 times the height of the gymnasium across these large swaths. So a large portion of water has been being pulled out, and it's been dropping at a much faster rate than it's been recharged. As a result, some of the high costs of that pumping of water have actually caused a lot of local farmers to lose their businesses because of maintaining the high cost of pumping is a challenge. And the lower and lower under the water, or further underground it gets, the more that problem occurs. The government has been subsidizing, helping farmers out, especially in those particular areas, for a long time, and that has helped deplete the aquifer further. And so there's a combination of things at work. Where are your priorities? Is it maintaining the aquifer? Is it maintaining farmer lifestyles? Is it maintaining food for the nation? And all of these things are kind of at odds with or working with one another in a synergistic manner. And so it's a tough balance between those two things. But the nature of needing lots of water for agriculture is creating this issue, to feed us. So that's where we're at. Biodiversity is also at risk in this situation as well. And so what else can we talk about with water? Well, we can talk about this thing called the cone of depression. So when you drill down into an aquifer and you start pumping water out, so initially, let's say this is your water table. As you pull out large quantities of water, the water drains in that area. Just like when you're drinking a thick malt and you start sucking down, it kind of falls in that space right there in the middle. That's your cone of depression. The problems with cone of depression is they can lead to other issues. So if it's pumped out too quickly, the water can't infiltrate back in there in a nice amount of time, and water or shallow wells in the area can go dry and run out of water because they're not far enough down. Now they're not in the groundwater anymore because of overpumping. That actually happened here with coal bed methane when it was happening back in 07-08 time. And then if you're overpumping along places where you have a coastal area, usually the water table and the seawater table kind of interact with it. There's an interface between the two. And when you suck out lots of groundwater, fresh water, it enables the saltwater to infiltrate down into what was once freshwater area, and now we're pulling saltwater out of wells instead of regular ones. So they can go dry, or they can cause saltwater to come in depending on your location. So both problems with cones of depression. Other issues that come with pumping out lots of water. You can create what they call sinkholes. They form on the roof of an underground cavern, right? So if there's an underground cavern like this right here, a big open space, which typically there isn't, typically it's within rock, but if that happens, a sinkhole is where that collapses, and now you have this big exposure to the cave. Subsidence is usually what occurs, and subsidence is when basically the water gets pulled out and it allows the land to shrink or depress in the spaces where it was at. And so you see this kind of settling of land in those particular areas. Well, that's a sinkhole, but it's the exact same look between the two. And this shows you subsidence over a long period of time. So they're keeping track of it. This is in California. In 1925, the land was right here. As they pulled out water over 30 years, it shrank to here. And this is a picture in 1977. And you can see that much the ground is settled because of the removal of water. And so there's benefits and drawbacks to pulling water out of the ground. It's useful for drinking and irrigation. It's available all the time, which is wonderful to have as a constant source for you. Exists almost everywhere on the planet, groundwater does. It's renewable as long as we don't pollute it and we don't overpump it. There's no loss of due to evaporation, which is a big way to lose water. And it's cheaper to extract than a lot of surface water applications. So there's a lot of benefits to groundwater. Now, some disadvantages. It can be depleted from overpumping. You can get sinking to occur because of overpumping. Aquifers can be polluted for extended periods of time because they take a long time to recharge. So it can be decades or centuries if you pollute one for it to come back. You can get saltwater infiltration on coastlines. You can reduce water flows into the surface water, and so that can affect the way the surface water, the creeks and rivers, flow. And then there's increased cost and contamination of really deep wells. And so combination of lots of different things at work, benefits and drawbacks to groundwater usage. That's the end of section 2.